Hello, this is Jeffrey Fox here again, Big Data Applications and Analytics. And we're doing the second unit in the Sports Informatics Analytics section. And this is lesson 2 of that unit, a rather short lesson, expanding on what Vince Gennaro did in the previous lesson. And this is it's actually the introduction of the video, but it's some of the more broad-based ideas of this concept of picture quality, or more generally, it can be expanded to batter quality. And this is from the introduction to that video. So in some level, in some aspects, occur before the previous lesson, but the previous lesson started with the blog, which did not have this discussion we have here. All right, so we're trying to look at looking at how batters perform against pitcher clusters. We motivated that and gave you pictures of clusters in the previous lesson. Here is where it all occurs. And we've already sort of discussed this a few times. Relief pitcher, who to put into a pitch hitter, and even the starting lineup. All of these can be affected by this analytics. And the current methods have this problem of small sample sizes, time that the matchups are old and unreliable. Sometimes there's just no data at all. And usually the way one does this, one does not use advanced sabermetrics, but just the particular results of the very few confrontations between the given batter and the given pitcher. So, say this is more detailed than is given in the blog. All right, so here is the basic, this is useful for batters and pitchers. You can use it to choose a pitcher or choose a batter, and because remember, batters and pitchers contribute actually similar amounts to success. Remember when we looked at WAR, the winning above replacement player, pitchers and batters each had the best pitcher and the best batters had a comparable contribution to their team's success. Even though batters play almost every game and pitchers play only one game in 4 or something. But then pitchers pitch in all innings, or at least a large number of innings, and batters just pitch 4 times or something a game. So remember, we looked at the features in the previous lesson. So these correspond to factors in the pitcher-batter analysis, at least some aspects of them. And we have the pitching style. That was then some interesting measure of pitcher quality, which was implied in some of the features we looked at before. The hitting style. Some hitters are going to be better at balls of a certain pitches of a certain type, or in a particular part of the strike zone. Whether the hitter's any good, the quality of the hitter, and the actual. We've also stressed many times how the size and weather and the weather, like in Denver, being high and very dry, that affects the results of the pitcher-batter confrontation, because if the ball goes further, it's more likely to be a home run than a catch. So here is an interesting plot of the OPS, which we introduced as a measure of batting involving slugging and on base. This is on base plus slugging. And then you could use some measures such as ERA or FIP about pitching. And you have here here's OPS, the y-axis, and then you plot you cluster the pitchers, the best pitchers and the worst pitchers. And you can see the OPS averaged overall encounters in Major League Baseball. They have a pretty large spread from 0.64 to 0.81, a 0.17 spread in OPS value, which is roughly hitting value. Then if you look at a particular individual batter, they actually are not necessarily equal to this average. So here's a batter, Elvis Andrus. He is actually got a similar percentage against poor pitchers as against good pitchers. He's a little better against poor pitchers, but not much. If you look at Chris Davis, he's enormously better against poor pitchers against best pitchers. So if you happen to know that in the game you're coming up against a pitcher who's really not as good as the average, then you're likely to make Chris Davis an automatic choice. Whereas if you have a top-notch pitcher, then you're more likely to choose Elvis Andrus, because just Elvis Andrus is doing very much better than Chris Davis, even though probably their average is similar. He's doing much better on great pitching. So this comes from data before 2013. I mean, remember, all this is statistical, but we're going to make a statistical model to make all our predictions. So here are some measures from his video as to what you gain by doing all of this, the return on investment. Remember, we had a 30 percentage guy. That was one of the Yankee hitters against a particular pitcher. And then there was another Yankee player who was 70th percentile. And that would, if you did that over 81 days, you would get 19 extra runs. So that's not trivial, because remember, one win is $5 million. So 10 runs is $5 million. So each run is sort of $500,000. So not a trivial amount of money. Shows you why you pay these players so much. If one run is $500,000, that's pretty interesting numbers. If you optimize the pitch 100 times, you'll get 9 runs. And if you choose the optimal relief pitcher 50 times, that's 5 runs. So here is a way of getting 33 runs, which is 3 wins, which might be all the difference between getting into the playoffs and not getting into the playoffs. So these optimizations are on the margin. So if you optimize, it may look as though you only get a smaller gain, but you actually only require a small gain because you have 162 games. And so a small number times 162 is going to take you from 95 wins to 100 wins. So that's pretty important for getting into the playoffs. And here's the final slide of this video, of this lesson. It's also the final excerpt from this particular YouTube video that I'll show in this class, and it represents future works where they're looking now not at the pitcher so much about the batter, pointing out there's different styles, and the different styles go into different parts of the ballpark. And this is what we call spatial visualization, where the balls spray around. Here's where the pitcher lands up in the strike zone with different with obviously the color representing the success. And so you can see Joey Votto and Josh Hamilton do different parts of the strike zone pretty differently. And therefore, by looking at where the pitchers are pitching in the strike zone, you can be rather precise about which batter is likely to succeed. Or else you could even teach a batter to change their style, maybe. I don't know why the batters always have this feature of looking at preferring the top of the strike zone, or here preferring the middle horizontal of the strike zone. So that's future work of Vince. And so unfortunately, I say it's so valuable, we'll probably never see it described in the open literature. But I'm pretty certain that from what he's told us, we can reproduce all of this. This is just, inverted commas, solving standard machine learning. And once you've decided on the features, and Vince has, though he's been very generous in telling us these features, he's using standard features, which we know from just reading Wikipedia on statistics, or reading other work on sabermetrics. So that's the end of this lesson. Thank you very much. This is Jeffrey Fox signing out. Thank you. Big Data Application Analytics meets baseball. Thank you.